Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today inshallah we will study about that let A be an element of order 2 and H is a subgroup which is generated by A and H is normal in G if and only if A belongs to zeta of G. Let's start. We have a theorem. Let A be an element of order 2. Order 2 means when we take the power 2 of A, it gives us identity element that would be E or 1. If with respect to multiplication will be 1 and with respect to addition will be 0. In G, then H is equal to or H is generated by A such that A raised to power 2 is equal to 1, or you may say that E identity element. Then H is normal in G. Normal means H is self-conjugate if and only if A belongs to zeta of G. Zeta of G means that all the elements of G are commutate with A. What it means that if G has elements A and B, then zeta of G will be A into A will be equal to A into A. It means that commutative law holds. Similarly, if A into B and B into A are same, then B will also be the element of G. Similarly, all the elements of G, those commutate or hold commutative law with A, those are the center of G or zeta of G. Zeta of G means center of G. We know that H is normal if and only if G belongs to G such that GH is equal to H. You may write it like this: H is equal to G inverse H G. Actually, this is the definition of normal subgroup, and this G inverse, when come this side, or you will multiply G on both sides, then this G into G inverse become identity element and GH is become equal to HG. So we know that H has only two elements, that is one should be A because it is generated by A, and we know that the identity should be in every group, so the other element will be identity element. If H has two elements and it is generated by A, then one element will be A and other element will be one, or in general form identity E. So in place of this capital H, we place its elements E and A. When G multiplied by E, it gives us G because E is identity element. When G multiplied by A, it gives us GA. Similarly, from right side, when G multiplied by A, it gives us GA, and when G multiplied by identity element, it gives us G itself. Here we can see that G is equal to G. We have no need to write it. So here we can write that left hand side GA is equal to AG, and we know that these two elements hold the commutative law, and these two elements G and G is from G and H is from A is from H. It means that A is the center of G because A is commutate with element of G. So as the definition of zeta or center of G means that, by simple example, I told you 1 minus 1 if these are two elements of G, we take 1 and we want to check either one is center of G or not. We this one multiply by this one from left side and this one multiply by this one from right side. We get the same answer, then it's mean that the first one, then this one is the center of G. If we multiply this one by this minus 1, 1 multiplied by minus 1, and then minus 1 multiplied by 1, it gives us the same result minus 1. It's mean that this minus 1 also center of G. Similarly, when we multiply A by the element of G from right side and from left side, it gives us the same result because this equal sign tells us that this give us the same result. It means that this A is the center of G. So A belongs to center of G as proved. I hope you understood. Thank you so much.